In this video, we are going to discuss about encoding of machine instruction. So, uh, let us now discuss an example of an instruction. Okay, so this is called as machine instruction. For example, add R1, comma R2, comma R3. Okay, so these two operand, this is called as source operand, and this is called as destination operand. Okay, and generally we use 32-bit registers to store the instruction. Okay, so since it is 32-bit, I'm going to assign R1 as 5 bits. So R2 also 5 bits, and R3 also 5 bits. Okay, and what is the operation it is going to perform? It is going to perform R1 is equal to R2 plus R3. Since this is a destination, these two are the um, source operand. Since this instruction is 32-bit, it is going to store in 32-bit register. Okay, so if I assign totally 15 bits for source and destination operand, so the remaining bits is for the opcode. So what is the remaining bits? So the remaining bits is 32 minus 15. That is nothing but 17 bits. So the 17 bits is for opcode. So what is generally the So the opcode it will indicate what is the operation to be performed. Okay. So how this instruction will look like? So the instruction will look like this. Okay. If it is a 32-bit register, so it ranges from 0 to 31. Okay. So 0 to 16 bits. 0 to 16 bit is for opcode, right? And I can write from 17 to 5 1 is 21, right? So 17 to 21. So 17, 18, 19, 20, 21. Totally 5 bits is for destination. So the destination is here is R1, right? So R1 will be here, and from 22 to 26. Okay, it is I can write it as R3. Okay, so source operand, and this is also a source. Okay, so from 27 to 31, it is another operand, that is R2. So this is how it will be. So this instruction is called as register. Since I am using all the operand are register, it is called as register operand format. Okay, so this assembly language instruction uh, symbolically express the action that must be performed by the operation circuitry. So this assembly language instruction here, this will express the action which is nothing but an addition, right? This is to be executed by the processor, right? So the assembly language instruction must be converted into a um, program, right? By the help of assembler. Okay. So what is machine instruction? It is nothing but zeros and ones. Okay. So the assembly language instruction, assembly language program must be converted into a meshing instruction that are encoded in a compact binary pattern, right? In the form of zeros and ones with the help of an assembler, right? So the assembler will do the job. Okay. So this is what it is understand by the processor. Zeros and ones only to be understand by the processor. So suppose instead of register operand, if I use a um, immediate operand, okay, immediate operand, immediate operand format. So what is immediate operand format? So example, here I am going to add R1, R2, hash some values. For example, 42. Okay, so this is nothing but this hash represent the immediate operand. Okay, so here what I'm going to do, so it ranges from 0 to 32, right? 0 to 31. And one of the source operand I'm going to assign it as, this is a source operand, right? So this is source operand. So here I'm going to assign R2. So it ranges from 27 to 31. So 5 bits it will occupy, right? It will occupy 5 bits, right? And this destination operand. So here it is going to perform R1 is equal to R2 plus 42, right? So R1 is here. So it ranges from 22 to 26, right? So 22 to 26. Okay, it is also 5 bits, 22, 23, 24, 25, 26. And the remaining will be your immediate operand. So this immediate operand may be 8 bits or 16 bits or 32 bits. Okay. So here I have assigned 5 bits for R1 and R2, right? So R1 and R2 is 5 bits. So totally I used 10 bits. So the remaining bits is so totally it is a 32 bit register, right? So 32 bits. So 32 minus 10 bits is 22, right? So 22 bits. So I can assign 16 bits for the immediate operand, right? So I'm going to assign 42. So since it is so I can assign mm, either 62 bits or 8 bits. Okay. For this 16 bits, it must be from 6 to 21, right? 6 to 21 is mm, 16 bits. So out of 22 bits, I am going to assign out of 22 bits, I am going to assign for immediate operand. So the immediate operand is 16 bits. So what is the remaining bits for opcode? So the remaining bits is used for opcode. For opcode is equal to 22 minus 16. So it is nothing but and 2 minus 6 is 6 bits, right? So 6 bits is assigned for opcode. So 0 to 5. So 0 to 5 is 16 bits that is assigned for the opcode. So this is a format for immediate opcode. In similar way, I can assign it for the call instruction. Okay. So next one is call format. So this call format is used to call the subroutine. So it is so it only needs the specific opcode and the immediate value, which is used to determine the address of the first instruction in the subroutine. So it must be call, okay, cache some address. Okay. So this represent the immediate one, and this address it will tell the mm, address of the first instruction of the subroutine. Okay, so for this one, um, so it is going to assign 6 bits, similar to that of the immediate operand. So it will assign 0 to 5 bits for opcode. Okay. So since it is 31 bits, 6 to 31 bits is for this immediate value. Okay. So this is how it will encode. Okay. So this is nothing but 26 bits. So it is 26 bits and this is 6 bits, right? So this is a format for the call instruction. So far we have explained about the basic concept of encoding the machine instruction. So different processor we have a different instruction set. So therefore, the details of the implementation will vary according to that. Okay. So I hope this video is useful for you. Thank you. Thank you very much for your patience.